extraordinary diversity of life on Earth is the result of a fragile balance that dictates the fundamental laws of life and allows different forms of life to interact, grow, and reproduce. The culmination of eons of evolution, life expresses itself in a colorful canvas that gives the Earth its unique character. Our own survival depends on this biodiversity, from the tiniest life forms to the very largest. The first forms of life arose in the oceans about 3.8 billion years ago. Today, they still support an array of fragile ecosystems that continue to astonish us as we learn more about them. But our planet's biodiversity is threatened. Today, plant and animal species are disappearing at an accelerated rate, probably unequaled in Earth's history. We must regain a balance between all species if we want to preserve the ecosystem services that nature provides. These services are what allow our own species to exist. Oceans cover over 70% of the Earth's surface. They represent 300 times more inhabitable volume than all of Earth's land habitats. It is estimated that more than 2 million species live in the oceans, about a quarter of all living species. Over 90% have yet to be documented by science. For scientists, unraveling the ocean's mysteries is a formidable challenge. Jean Lemire, mission leader of the oceanographic schooner Седна.
Our mission, 1,000 Days for the Planet, is in the spirit of the great explorers of yesteryears. With scientists, we are traveling the world's ocean to better understand the conservation challenges that we all face. And there are many, many challenges, because the ocean still bears the scars of our past abuses.
The history of our exploitation of the oceans is not a glorious one. In order to supply European lanterns with oil, the great whales were hunted to the brink of extinction. We are still living with the consequences of this carnage today. Many species are still on the endangered list. Fin whales, blue whales, minke whales, right whales, and dozens of other species are struggling to recover from our bloody past. Despite the fragile moratorium that now protects most species, some countries still hunt whales in the name of science or of culture.
That is ridiculous because we don't need to take the whales for science, in quotes, especially if you use the subproduct of that science to sell it in the market.
Scientific whaling, overexploitation of ocean resources, illegal fishing. The pressure we place on the oceans has become unsustainable, and these already considerable conservation challenges have been complicated by even more insidious problems, such as plastic pollution.
The gyre, where a lot of it concentrates, some people say it's the size of Texas or even twice the size of Texas, so we're talking incredible amounts of items out there and debris.
The oceans have always supported life, but if that life is today being threatened, is it not time to rethink our relationship with the ocean's inhabitants? Of all the great oceanic migrants, whales are without question one of the most emblematic symbols of conservation. The Седна has stopped in the Azores, The rich Atlantic waters here attract 24 species of cetacean. Though they have a long history of whale hunting, the Azorians gave up this tradition in the late 1980s. Richard Sears has studied whales for over 30 years. Every spring, the great diversity of species off the Azores lures him here to study the migratory patterns of large Atlantic whales. But it's not an easy task. Following these great migrating nomads of the oceans is a challenge for scientists.
OK, donc, on se met une heure de départ à 13h, 13h30, heure locale. Richard travels the world to photograph different species. He introduced me to the fascinating world of whales. We often work together, and I have traveled with him to different oceans, always with the same passion, the same desire to learn more about them.
Scientists are a bit like the hunters of yesterday. In modern science, the camera has replaced the harpoon. The quest is the same, but the goal has changed. Today, we have a real desire to protect whales. These species are slowly recovering from the excessive commercial whaling that forever changed the face of our oceans. Among the victims of commercial whale hunting, the right whale. A symbol of our past abuses, the right whale is a coastal species, slow and easy to approach, and was a preferred target of the harpoon. In less than 70 years in the 19th century, North American whalers killed over 190,000 right whales in the North Atlantic. Hunting right whales was banned in 1935, but the damage was done. At that time, the population was estimated at fewer than 100 individuals in the entire North Atlantic. Today, after over 3/4 of a century of protection, only about 350 representatives of this severely threatened species remain. As hunting techniques improved, whalers were able to go after fast-swimming, ocean-going species like the blue whale, the largest animal on the planet. Up to 30 meters in length, and over 100 tons of power and grace. Before commercial hunting, the worldwide population of blue whales was estimated at over 350,000 individuals. Over the past century, nearly 99% of this population was slaughtered. Richard Sears is an expert on blue whales. He has developed a photo ID technique so that scientists can now identify and monitor the movements of this species, which is still threatened with extinction.
The pigmentation pattern on the sides of blue whales allows us to reliably identify individuals. We have identified about 325 blue whales in the North Atlantic, including many photos taken in the Azores. We have many partners here who take good pictures that allow us to match photos from year to year. In this case, Johanna, who works here in Horta, photographed this whale in 2002, and the animal returned in 2010. That's a long time between matches. I think it's the longest match we've had here in the Azores.
For over 30 years, Richard Sears has compiled photographs of blue whales. His catalog includes several hundred individuals in the North Atlantic, but their migration routes remain completely shrouded in mystery. The humpback whale was also hunted all over the world. It is estimated that in the mid-19th century, the worldwide population of humpbacks was over 125,000 individuals. In less than 100 years, nearly 95% of the population was wiped out by whalers. By the mid-1960s, only a few thousand survivors remained. In the 1980s, a broad scientific effort led to a series of techniques that today form the basis of our knowledge about this species. Among these techniques is the identification of individuals using photographs of the tail flukes.
Here's an example of photo identification of a humpback whale. It's the equivalent of a fingerprint for this species. They are kind enough to raise their fluke when they dive, and the pattern on the underside of the tail is different for each individual. It can vary from totally black to totally white. Studying individuals helps us learn about the species, and now we have extensive catalogs of humpbacks all over the planet. All this data makes it a powerful system because it allows us to learn about the movements of these animals, their migrations, their numbers, and newcomers to the population.
This technique led to the discovery of gathering sites for the species in the North Atlantic. These feeding areas are frequented by different humpback whale populations from spring to fall. Scientific research has shown that populations are faithful to these gathering sites. A humpback whale that frequents coastal waters in a particular area will generally return to the same place the following season. Every winter, most North Atlantic humpbacks migrate south to Silverbank off the coast of the Dominican Republic. They gather on this protected shallow area to mate and give birth. But scientists only discovered the importance of Silverbank in the 1980s.
84, it was my first time I saw a whale. We didn't know even where was located Silverbank. We heard about it, but we didn't know. The density of Silverbank, if it's not the highest, it could be one of the highest of the world.
Nowadays, everything we know about the animal's movements between here and the north seems obvious. But back then, we knew very little, almost nothing. We knew they came here, but it had never been studied in depth. So we came, and we made a great many photo IDs. Each of us recognized animals from the different areas we were working in.
Over 30 years after the discovery of Silverbank, scientists are back. They are now trying to determine the migration routes used by humpback whales between Silverbank and their different feeding areas. For biologist Amy Kennedy, this is a chance to deploy satellite transmitters.
It's the end of the season, so there are lots of males in large groups who are very active. There's a struggle between the escort and what we call the challengers. The escort is the male closest to the female, and all the other males fight to be as close to the female as possible.
Before installing the satellite beacons, the scientists try to identify the sex of the animals. They use a crossbow that shoots an arrow with a hollow tip to take a sample of the animal's skin and blubber. Using genetic profiles, scientists can determine the kinship among the different individuals.
So we have developed also a large database of whale tissue. Besides the samples that were taken for DNA studies, we also developed the archive. So it's a genetical catalog. We have whales identified genetically, and this, together with their photo IDs, they complete the information. And if anybody wants to study the population, we have another, let's say, another piece of the sample, which is the archive. They are intact as they were taken, and they are frozen, keeping their qualities. So if anybody needs to do any further study, like molecular study, biomolecular study, so they just need to go to the archive and take a piece and interpret it.
To deploy the satellite transmitter, the scientist's boat must slip into a group of males, competing for the favors of a female. It's a delicate maneuver.
I need to be as close as possible, and when I shoot the tag, it's not a matter of just hitting the whale. I could shoot from a long distance and just hit the whale. It has to be in a really very specific spot where the tag goes. So I'm trying to tag very high on the animal. I'm trying to tag just below the dorsal fin and just below the hump. And that's because the tissue there is very dense. So I can track the whale underwater. I see what the animal's doing. I indicate to Oswaldo to speed up, slow down. I can see the whale. You can tell when it's coming up. I get ready. But when I know the whale's gonna come up, and preferably when it arches, I'm focused on a perpendicular shot directly in one little spot, and I really, in my head, I see almost nothing else. Oh, that's perfect. It's good, I'm really happy.
The transmitter is attached to the animal's back using a modified line thrower, which shoots the transmitter's anchoring hooks into the whale's flesh without causing too much injury.
Position very high and in very dense tissue, so it will stay in a long time, and it will transmit every surfacing. 11.
That's the tag.
Coming up. Oh, that's perfect. It's good, I'm really happy. I'm happy with today. The tags that we got on were in good positions, and I'm relieved, and I can't wait to start tracking them. I don't want to get to the computer now and see where they go. So this is the 4 whales that we tagged on the 2nd. So this is 4 full days of track for all 4 whales, which is really exciting because the cool thing is that all 4 of these whales were tagged in the same exact group. They were all there together, and then you can see that each one of them has gone a completely different direction. One whale has stayed almost exactly around the same spot that we tagged it. One whale has moved over to Mouchoir Bank, and one whale looks like it's starting its migration up north. And then another whale looks like it's moving to the southeast, which is really unique. And we hope that these keep lasting, because we'll be able to check them every day from here on out. And I check them a lot, so constantly checking my tags and making sure they're all working and see where everybody's going. And
you know, it's very important, this preliminary information, because we have seen that in just 5 days after the tag, the whales are outside of the boundaries of the sanctuary. So for our country, this information is very important in terms of maybe developing new policies for conservation, maybe expanding the boundaries of the sanctuary. You see how important it is for the sanctuary to be included in these areas.
So can we sort of amuse ourselves with the thought of where these guys might be going? And I would say that the Mouchrock Bank guy has a good chance of going to the Gulf of Maine.
Yeah, no, I think that that's a very good guess. I think these other whales, if they move offshore and then start heading north, they have a straight shot to somewhere else. So.
Iceland or maybe even Norway?
Yeah. There are very distinct feeding grounds in the North Atlantic, and they're characterized by high site fidelity, which means that if you go to the Gulf of Maine, you are likely to see whales that you've been seeing for generations. And it's the same with all of the major feeding grounds, Norway, Iceland, Newfoundland, Greenland. And it's all driven by the mother. So the mother will bring her calf there on its first migration. The calf remembers that migratory route and will continue to return there throughout its lifespan. Researchers in all of the feeding grounds have several generations of whales. I mean, we'll see a calf and we'll know its mother and its grandmother and its great-grandmother and its great-great-grandmother, which is awesome, just really, really great. It really shows that these whales are multinational world travelers. They are not Dominican whales, and they're not American whales or Canadian whales. They are whales of the entire North Atlantic. They cross so many different borders across so many different countries. And so we need to all work together to help preserve this species.
While some of the transmitters operated for a limited amount of time, whale number 87765 broke all records by transmitting for 57 consecutive days. The migration data of whale 87765 stopped off the coast of Newfoundland. Where will it go next? Will it remain around Newfoundland, or will it continue its migration towards Iceland, Greenland, or even Norway? The migration data confirms that humpback whales, which do not eat for the entire 4 months of their breeding period, begin to feed again as soon as they arrive in the rich waters of the north. A humpback whale requires 2 tons of food per day. But can the current state of the oceans support any eventual population increase of these species? The composition of the oceans is undergoing a transformation. Their biomass has declined sharply since the start of human exploitation. For whales, seabirds, turtles, sharks, and all migratory species that rely on the oceans, the future is more uncertain than ever.
The food that marine populations need to survive is in decline. Scientists are worried about the growing number of dead zones in the oceans. Off the coast of Bermuda, we met with scientists from the Corvette Kramer, a research vessel studying the composition of the oceans. They recently discovered a new continent of plastic in the Atlantic Ocean.
Sea Education Association essentially is an educational organization that teaches students about the ocean. We do a lot of basic measurements, and the value of those relatively simple measurements is that we go year after year, more or less to the same places. So for instance, our plastic research, where we're doing relatively simple things, each student project is relatively simple, but they build on each other over time. So what they're going to do now is set up the new stun net, and this is our old standby net. We've been doing it the same way for 30 years. And realistically, it may not be the most efficient way to do it, but we don't want to change what we're doing because we have a long-term database, and so we want to keep doing it the same way every time.
A few years ago, the discovery of a substantial accumulation of plastic in the Pacific Ocean came as a bombshell all over the world. No one suspected the same thing in the Atlantic, where the Sea Education Association has been gathering data for 20 years. But in fact, concentrations of plastic in the Atlantic equal or surpass those observed in the Pacific. And this invisible patch extends into the feeding areas of the ocean's great migrators.
The plastic comes from land. We think that probably around 80% of it is actually shore-based. So it's from you and me. We're trying to do our best. We're trying to recycle, but you know, it's a windy day. A piece of plastic, the yogurt container blows out of the recycle bin, gets in the water system in the river, ends up in the ocean. I just wanted to show you some of the kinds of things that we find. This piece is broken, and you can see it's starting to get brittle. It's being weathered by the sun, by just wave action, getting quite brittle into small pieces, easy to break. And we're seeing numbers as high as 250,000 pieces per square kilometer, or even higher. Now granted, most of those pieces are tiny millimeter-sized pieces, but still, it's a big ocean. When you extrapolate that to the size of the ocean and the patches, it's a lot of plastic.
Our plastic garbage ends up in the ocean, where exposure to sun and waves weakens its structure and breaks it into countless tiny pieces that are now inundating the oceans. What is misleadingly called a garbage patch is actually more like a soup of tiny particles, often floating just below the surface.
Did you see some increase of the numbers of pieces of plastic over the 22 years of research?
No, in a lot of variability, but no real increase over that time. So the question is, where is that plastic going? And one idea is, of course, it could be the microbes.
And yet, our society is using more and more plastic. Microbes and bacteria may play an important role in breaking down this plastic, but at what price?
It's hard to say whether it's good news or bad news. Is it good news that it's making plastic go away? There are a lot of additives in plastic, and plastic also acts as a bit of a sponge, absorbing toxic chemicals. So you could ask yourself, is it better for those chemicals to stay in one place in the plastic or to be released into the ocean?
If plastic acts like a sponge, where do all those toxins go? Recent scientific studies in the Pacific Ocean estimate that fish consume between 12 and 24,000 tons of plastic every year.
And it still isn't exactly clear how much these toxins transfer up the food chain from plastic. There has been some work done to show it does happen, but absolutely, we're polluting the ocean, and then it does stay in the food chain, and then we eat the fish.
We produce about 300 million tons of new plastic every year. Half of this, about 150 million tons, is only used once, then thrown away. Worldwide, less than 10% of the plastic we produce is recycled. The development of plastics began in the 20th century. It is estimated that hundreds of millions of tons of plastic have found their way into the oceans in recent decades. Much of this garbage is still floating today. Plastic in the oceans accumulates in specific areas all over the planet, where the major ocean currents concentrate the floating plastic. These immense vortexes, called ocean gyres, draw in and accumulate garbage over wide areas. This pollution ends up in 5 major ocean basins: the North Atlantic, the South Atlantic and Pacific, the Indian Ocean, and the most well-known ocean gyre, the North Pacific. The Midway Atoll, north of the Hawaiian Islands, seems incredibly remote. But for many Pacific seabird species, it is an important refuge and nesting site. The island's most abundant bird is the Laysan albatross, classified a vulnerable species. They come here to lay their eggs and raise their chicks, far from any predators. But the real threat to the Laysan albatross is much more insidious than any predator.
John? Yes? You look at Midway, and it's so remote. It's in the middle of this beautiful Pacific Ocean, and your first thought is it should be pristine, untouched, white sand beaches with nothing on it.
A lot of disturbance.
But instead, we see lots of plastic.
Here, and then just beach disturbance. So it's been a slow.
The winds and the currents of the North Pacific Gyre combine to concentrate plastic in this area. It is not unusual to see the beaches of Midway littered with all sorts of large floating objects, which must continually be collected. But a closer look at the white sand beaches reveals the true catastrophe. Every new wave washes up more tiny particles of plastic and a multitude of garbage that pose a real threat to the island's abundant wildlife. Volunteers come from all over to try and clean up the shores. But the work must be repeated week after week, the result of decades of carelessness and indifference. The same tsunami that hit Japan in 2011 also washed significant amounts of garbage floating in the area onto Midway. The huge wave flooded parts of the island, carrying many large objects far inland. But biologists are more concerned with smaller bits of garbage, transported here not by water, but by air.
The way that plastic is arriving in the interior is that the adult albatross are foraging 1,000 miles or so from here. They're picking up the plastic because they either mistake it for food or food is attached to it. They bring it back here and they regurgitate it to their chicks. And this happens about every 3 days or so this time of year, and the male and female take turns, and they're feeding mainly squid to their chick. You know, it's really difficult to see, but if we look closely, this could be the point where a little bit of plastic is transferring from the adult to the chick. At some point, some are able to regurgitate a pellet or a bolus and get rid of the plastic, and others don't get rid of it, and as they die, it remains inside their body. This bird is a couple months old, so should we open it up and see if there's plastic inside? Okay, we'll look inside this one and see what we have. And right away we see plastic, yeah. So here's a couple of larger fragments right there, and yeah, so this bit of plastic is definitely part of a larger piece, and some of the plastic might have sharp edges, and they could actually puncture the stomach lining, so that might be a possible cause of mortality for this chick. So it could be the load of plastic plus sharp edges and then contaminants as well that are part of it.
That's probably from a grocery bag or something, you know. What do you think?
Yeah, there's a good chance.
Yeah.
Oh, wow, that's an interesting piece. We see those occasionally, and we think they're some sort of fishing float, perhaps from Asia, so that's a big item.
Yeah.
Definitely takes up a lot of space. The plastic load in healthy albatross compared to albatross that were found dead, and there was a significant difference, almost twice as much plastic in the birds that died compared to the healthy ones. And so we can't definitively say that plastic kills albatross chicks, but I think what we can say right now is that it is additive to their mortality. Most of the chicks die from dehydration, and so if you think about plastic taking up physical space in the bird's stomach, they have less food, less moisture, and they might be more apt to dehydrate.
Incredible. In 5 or 10 minutes, I collected all this. It's really upsetting. We find a lot of bottle caps and lighters. A lot of lighters. And many floaters like this. They look a lot like what the birds would find. This is a squid without the head. Clearly, they look very much alike. Here's a lighter, and here's a squid. It's not surprising that the albatrosses mix them up.
We see a lot of spacer tubes that are part of the oyster aquaculture industry in Asia or in Japan. So they have these lines that go down, and they have these small little oyster cages. And in order to space them on the line, they have these plastic spacer tubes. And when the line breaks apart, the spacer tubes are all over the ocean. That's pretty common. And I suspect some of the items are so big that they can't regurgitate the pellet. And maybe, again, that's linked back to mortality. If they physically can't get that stuff up, maybe that's another reason why they perish as well. Some of the really surprising things that you find in there, toothbrushes. I mean, you'd think a large toothbrush couldn't be swallowed by an albatross, but it is. Syringes, unfortunately. All sorts of kids' toys are in there, light bulbs, so lots of really interesting things. And if we extrapolate for the entire population, that's about 5 tons of plastic that the adults are feeding to their chicks each year. That's really amazing. Even if we stop putting plastic in the ocean today, it's going to be decades before it's all cleaned up. You know, there's just so much out there. In fact, the gyre where a lot of it concentrates, some people say it's the size of Texas or even twice the size of Texas. So we're talking incredible amounts of items out there and debris.
The age of plastic should have been a revolution for the world. But the invention of nearly indestructible synthetic products has instead become a real menace to the future of the Earth's ecosystems.
Once it goes into the ocean, nobody's figured out the appropriate technique to be able to start to clean up the ocean. We basically have to wait until it reaches land. The best thing that we can do is to make people aware and prevent it from reaching the ocean in the first place.
The solution has to start with us, with our use of plastic, but above all, by how we get rid of our garbage. It's not that complicated. We don't have to reinvent the wheel. We just have to recycle our plastic. Some missions are harder than others. Coming here to Midway has been pretty tough. Of course, I expected to see plastic from the oceans, but I never thought I would see so much. I think we have gone too far. The oceans are filled with plastic. Each wave brings more, and there are a lot of waves. It's clear that the presence of humans is felt all over the planet now. And unfortunately, I don't mean that in a good way. Sometimes human nature is pretty hard to understand.
Protecting the ocean's great migrators is still a challenge for scientists. We must take inspiration from our successes to build momentum and create the vital wave of change that will determine the future of our world. Today, the humpback whale is undergoing a population boom all over the planet. In calving areas, like the Dominican Republic, calves are being born in greater numbers, helping to secure the future of this species. The reconciliation between our two species is translating into an apparently shared curiosity. No one who has come face to face with a whale has not come away profoundly moved.
Well, the mother came up kind of unexpectedly too, and I didn't know where to go.
She made a full turn.
It's incredible to see how calm and serene they are. You're not scared. You're not scared at all. These are what I call little moments of eternity. They stick in your head, and they're gonna be there forever. It's an amazing feeling.
It was fantastic. I've never had an experience like that before.
Amazing. Amazing.
Incredible. After an experience like that, you can die happy. Incredible.
We have managed to save most whale species from extinction because people mobilized against whaling. We no longer need whale blubber to produce an oil that was once considered irreplaceable. Citizen mobilization may be the salvation of the oceans if we are going to rescue them from the devastating effects of our own consumption habits.
I'm by nature an optimist. I realize it's a very serious problem and it's going to get worse before it gets better, but I'm an optimist that we can at least stabilize the situation.
Hopefully, over time, we can make some positive change and reduce the amount of plastic that's going in the ocean and reduce the amount that albatross are getting. Because ultimately, it's going to affect you and I and all levels of the food chain. We see the same phenomena. The small fish have plastic in them, the small zooplankton, all these different things. So we need to make a difference.
When industrial whaling ended, there were only about 5,000 humpback whales left. Today, there are over 60,000 in the world's oceans, a great conservation success story. When people mobilize, they can accomplish great things. Today, witnessing the magnificent spectacle of the Earth's last giants is certainly one more motivation to conserve the extraordinary biodiversity of our planet.
Our oceans are facing considerable conservation challenges, but with better science we are beginning to understand them so we can better protect them. The grand spectacle of life continues in all its stunning beauty. But time is running out if we want to preserve the fragile balance of biodiversity. A biodiversity that allows all forms of life to thrive, including our own.